All right, so we are on Unit 2, Day 3 still, and we're going to talk about the last type of transformation we will have, which is called a dilation. Now, a dilation is when something gets bigger or smaller. So the shape the shape don't change, but the size changes. Okay? So this one is the only one that is not a rigid motion. Write that down and circle it. Not a rigid motion. Remember we kind of talked that rigid motions are transformations that kept the same size. So rotations were rigid motions, reflections were rigid motions, and rotations because they kept the figure the same size. So since dilation is changing the size, it is not a rigid motion. So anything that asks you which one preserves the size and it has a dilation in there, you know it's not going to keep the same size. Okay, so you'll see like benchmark type questions and even EOC type questions that ask that. Okay, there's a lot of transformation stuff on those tests. So if it says which one will preserve the size, anything that is multiplied by a scale factor, it looks like a dilation, will not. All right, anything that's rotated will keep the same size. If it's reflected, it will keep the same size, or if it's translated, it will keep the same size. But if it's dilated, it will not keep the same size. So it's not a rigid motion. That's the clue word. Another word is also isometry. I think rigid motion is the term they use most often now. Isometry is considered the old school word. Okay, some things in math are old school words like Cartesian plane. Y'all know what a Cartesian plane is? It's just the x and y axis, right? We just shorten it to the coordinate plane now. But anyway, so a dilation is an enlargement or reduction of a figure. If something is enlarged or reduced, that is called a dilation. All right, the scale factor is a number that indicates how much the figure will enlarge or reduce. Okay, so the scale factor is a number that tells us by how much we enlarge or reduce. So if I have a scale factor of 2, it's going to double in size. If I have a scale factor of 1/2, we're going to shrink it to half of what it is. Does that make sense? Okay. So the variable we call for a scale factor is K. Okay, we call that variable K. When K is a number that is greater than 1, then you will have an enlargement. So when K is less than 1, whoops, you're going to have what kind of dilation? A reduction or a shrinkage, right? All right, it's going to shrink or reduce. So what kind of numbers are less than 1 besides negatives? I'm not talking about negatives because your K will never be negative. Fractions that are smaller than 1. Can a fraction be larger than 1?
No, that's a mixed number.
No, it's not a mixed number. It's actually an improper fraction, right? Okay? So yes, you can have numbers that are greater than 1 that are fractions, and those would be in the form of an improper fraction. So an improper fraction would be an enlargement. Okay? All right. So we're just going to work some examples. Let's look at number 1. All right. So just like what we've been doing. Sorry, y'all. I tried to make it bigger and I got all over the place. Just like we've been doing, they're going to give us an original figure, and then we have to use the dilation, and then we'll have a new figure. Okay, so let's go ahead and graph the original triangle, please. I'm going to do mine with blue. Y'all bear with me. Okay, so draw and label that triangle, please. And I think these are -10 to +10. So we're not going -8 to +8 anymore. We're going -10 to +10 in both directions. Yeah, they changed it on it, but at least it's the last lesson, so it's not going to be too crazy. Negative. I'm sorry. It's small for me too, and then mine keeps jumping around because the touch screen is going crazy. I'll try to make my pen a little fatter. Okay. That's a little better. All right. Does y'all's triangle look something like mine? Yes or no? Mine looks sloppy because I'm trying to trace over it, and I apologize. All right. So my scale factor is 2, right? All right. So if my scale factor is 2, y'all, it's so easy to do a dilation. You just take all your ordered pairs and multiply the x and the y by the scale factor. That's it. That's it. So for r is negative 5, 1. So r prime, you double everything and get what? Negative 10, positive 2. And then for s, what do you get? And then for t, you're going to do what? 4, negative 2. And then you graph your new triangle. Negative 10 up 2. What the heck? Go away. Go away. I don't know what this random stuff is. And then sometimes you overlap when you draw a little bit. Y'all, it's seriously that simple. You take your scale factor and you multiply it times all of your coordinates. Now, what happens if you multiply your coordinates times a fraction that's smaller than 1? Right? It's like dividing, right? So if it was a scale factor of 1/2, you would divide by 2. Okay? All right, let's just do a few of them where we don't actually graph it, because I trust y'all can graph points by now, right? We've kind of done it for 3 days straight. So let's just focus on for a second the coordinates of a few problems. Is that okay? Okay. So on number 3, the scale factor is what? 1/2. So what do you think the coordinates for J prime are going to be? Negative 5, 1. What do you think K prime is going to be? Negative 1, 4. And what do you think L prime is going to be? 3, 1. And then M prime, negative 1, negative 2. Okay? So sometimes if your scale factor is a fraction, you might get like 2.5 or something like that. So keep in mind that that could happen. All right? So like on this one, let's go ahead and do number 4's coordinates, just so y'all are familiar. First of all, is this triangle going to get larger or smaller? Smaller, because 1/4 is less than 1, right? So this is going to be a pretty good reduction. All right? So that means multiplying every thing times 1/4 is the same thing as dividing by 4. So if you're using your calculator, if you're not sure what you're doing, divide them by 4 and That'll tell you, even if it's a decimal, it's okay. Because, you know, when we're graphing a decimal, like if I want to go to like 1.5, I go to over 1 and over a little bit halfway more, right? Right. So yeah, we can graph a half just by estimating where it is on the grid. All right. So what's -4 divided by 4? -1. What's 8 divided by 4? 2. And then what's 10 divided by 4? 2.5. And it's positive 2.5. And then 0 divided by 4 is 0. What's -2 divided by 4? -1/2, right? And I don't care if you tell me decimals or fractions on these. And then what's -8 divided by 4? -2. Whoopsie. Lordy. Exit. Go away, keyboard. Craziness. I got to get used to it. All right. So like I said, when you want to graph that 2.5, 0, you go over 2 and then over a half more. Does that make sense? Does that make sense? All right. Flip over 2. And y'all can use your calculator on these. Okay. So on number 5, the scale factor is 5/2. So if you want to use your calculator, isn't that the same thing as multiplying by 2.5 on number 5? Right? So you can just use your calculator and multiply by 2.5 if you want to. And so is number 5 going to be an enlargement or a reduction? Enlargement. What about number 6? Enlargement or reduction? Reduction. What about number 7? Just like number 1, isn't it? So it's an enlargement. 8's like the last one we did. So number 9, enlargement or reduction? Enlargement is an improper fraction. That's 1.5. That's bigger than 1, right? Number 10, enlargement or reduction? Reduction, because 3/4 is less than 1. All right. Y'all look over at number 11 and number 12. What is different about these two? Yes, they give you the original and the new picture, and you have to tell what the scale factor is. So it's kind of like working backwards. All right. The way I like to do it, now we start with D and go to D prime, right? Right. So which one's bigger? The original or the new one? The original one, and the new one's smaller. So what happened, an enlargement or a reduction? A reduction happened. So I know that whatever K is, it's got to be less than 1. Right? Right? So the way I like to do it is just write down ordered pairs. Like for D, it starts out as what's the ordered pair for D? I think these are 0, 6. They went back to 8, didn't it? 0, 6. And D prime is what ordered pair? 0, 2. And then let's do another one, for example. Let's do E. E is what ordered pair? 6, 0. And what is E prime? 2, 0. Okay? So I like to find a coordinate like 6 to 2. What happened? Well, if you do the new divided by the old, if that makes sense. New divided by old. So like you see how the Y values are 6 and 2? So if you do the Y value on D prime is 2 over 6 and then reduce that fraction. What does 2 over 6 reduce to? 1/3. And your scale factor is 1/3. And you can check that because same thing, 2 over 6 is 1/3, right? F might be a little bit better picture for you because they're different coordinates. So F was what ordered pair? -6, -3. And F prime was what ordered pair? -2, -1. Okay, we already tried 6 and 2 1,000 times, right? -2 over -6 reduces to 1/3. -1 over -3 reduces to 1/3. Right? So you do new coordinate over old coordinate. Does that make sense? So Look at this one. What happened here, an enlargement or a reduction? Enlargement, because the original one is the inside trapezoid. Y'all see that? And because the new one's the outside, because those have the little primes. All right, so somebody give me a coordinate for x. It's 2, 0. What's x prime? 8, 0. What is, let's just do w. What's w's coordinates? -2, 2. And what's w prime's coordinates? Yeah, and I think that's enough to do it. So new over old. What's 8 over 2? 4. Y'all see what I did there? Check those x's, and then you can check it. That'll get me 4. That'll get me 4. And if you keep going, they should all get you 4. So the scale factor is +4. So do new over old to get your scale factor. All right, that is all about dilations. Have a good day. Amazing.